Hi, welcome to my channel Mathemagic with MOhsin Raza, and today I come up with a question that appears in the British Mathematical Olympiad in 1996, and that question says that to find the all solutions in a positive real numbers that are a, b, c, d that satisfies this system of equations, and the system of equation is a plus b plus c plus d is 12, and second one is abcd equals to 27 plus ab plus ac plus ad plus bc plus bd plus cd. So before going to solve this question, if you haven't subscribed the channel yet, so please subscribe the channel to watch more interesting and informative videos like this. And thank you, and let's start solving this system. So first of all, the equation was a plus b plus c plus d equals to 12, and the second equation was a b c d equals to 27 plus ab plus ac plus ad plus bc plus bd plus cd. Okay, so we have to solve this system of equation. So before going to solve this system of equation, first of all, we recall a relationship for the arithmetic mean and geometric mean. So we know that if we have n numbers, let's say those numbers are a1 a2 and so on an, then the arithmetic mean is defined as the sum of these all numbers divided by n. Okay, and moreover, the geometric mean of these n numbers, if they are all positive or even the product of them is positive, then it is defined to be like a1 a2 and so on an, and taking the nth root of them. Okay, or even power of 1 over n. And we have also seen that this relationship satisfies this arithmetic mean is greater than geometric mean, and you can see this in the description for the video where we have proved this one, that arithmetic mean is always greater than or equal to geometric mean. Okay, now we first of all compute the geometric mean. So what is the arithmetic mean of these numbers and the geometric mean of these numbers for the second equation? So we have numbers, and these are the six numbers that are AB plus AC plus AD plus BC plus BD plus CD. And if we take the arithmetic mean, then we divide this sum by 6, and if we want to find the geometric mean for these numbers, then that will be the product of all those numbers, that will be AB into AC into AD, BC, BD and CD. And if you look into them, then we get what this whole thing is: A cube, B cube, C cube and d cube. Okay, then taking the nth root, and here n will be the 6, then the sixth root of it will make it geometric mean. So geometric mean for these numbers will be what? So that will be a b c d whole cube, and the sixth root, which means that 1 over 6, which makes it square root of a b c d. Okay, so from using this relationship that arithmetic mean is greater or equal geometric mean, makes this whole sum to be greater than 6 times a b c d square root. So that second equation will become what? So that second equation will become a b c d equals to 27. So now it will be 27 greater than or equal to 27 plus 6 times a b c d, that I have plugged by that relationship, that value in the second equation. Now let's assume that this number is, let's say this is x. So if this is x, so we get what? X equals to under root a b c d, and which makes it x is greater than or equal to 27 plus 6 x, and here that will make 6x square. So we take the all the numbers to the next other side, and we get what? We get x square minus 6x minus 27 is greater or equal 0. And now we have to factorize it, and we can see that by taking the midterm of this we get x square. Here x square minus 9x plus 3x minus 27 greater or equal 0, which implies that this will be equals to x into x minus 9 into plus 3 into x minus 9, which makes it greater or equal 0. So from here we get x minus 9 into x plus 3 is greater or equal 0. Okay, so this we get here, which says so this implies that uh, from here we which combine if we take this thing, that this says that x is greater or equal 9, because that cannot be okay, that's also true, but this is x greater or equal 9 is a solution to this inequality. You can check verify just by taking that. If we take the both to be positive, then it will satisfy this condition, and if we take the both to be negative, then it satisfies the negative condition, which is not our interest. So that's true. So here this is the common part for the both to be positive. So this is x greater or equal 9, which says that we get this says that this is under root a b c d is greater or equal 9. Okay, so what we had up to now, so we have the two equations up to now. The first one was a plus b plus c plus d equals to 12. The other one we had a b c d under root is greater than or equal to 9. Okay, so now we have seen, if we use the geometric mean relationship for the first one as well, then what we get? Okay, so first of all, we plug this into that. So that says that if we take the square root on both sides, and by taking that, then that will make it a b c d under root 4 is greater or equal to a plus b plus c plus d over 4. Okay, so you know that this is actually what? This is 3, right? This is greater or equal 3, and this is also equals to 3. So that means that this can be replaced by 3 by this number. And we know that by the arithmetic mean and geometric mean inequality, which says that arithmetic mean is always greater or equal geometric mean, which says that a plus b plus c plus d over 4 is greater or equal to a b c d under root 4, which shows that these two must equals, and they must equal. It means that this thing a plus b plus c plus d over 4 must be equals to 12 over 4, which is equals to 3, which says that all of the a's and b's should be 3, otherwise that will not be true. So that's why A equals to B equals to C equals to D equals to 3 is the only solution for the system of equations. Okay. So thank you for watching the video, and if you haven't subscribed yet, so please subscribe the channel to watch more interesting videos. Thank you.